Welcome to Global Future School. Students, this is your first year chemistry class. I'm Dr. Jazbano, and the topic for today's discussion is percentage composition from chapter 1. Chapter 1 is stoichiometry. Students, in this topic, the percentage composition, we will know how to find out the percentage composition of elements in compound. And even students, after completing this topic, you will be able to calculate the a yield that is named as a percentage yield. We will discuss this percentage yield, theoretical yield, actual yield in our next topics. So students, I will just quickly recall you about percentage. You are already familiar with the percentage word, like this battery is like it's 100% or it's 23% or 25%. Sometimes you talk about your marks that I got 90% marks in exam or 80% marks in exam, and like the first division is on the 60% marks and whatever. So this is already a quite familiar word for you, and here is just I am recalling you about the percentage. This is a number or ratio expressed as a fraction of 100. It means if you have something and consider this is a whole 100, it's whole 100, and out of this 100 the part or the number or the ratio, that is the percentage that we expressed in using the term percentage. Similarly, it can be a quantity, it can be a mass, it can be number, and this out of 100. I have got this a picture in front of you in the form of like this is a battery or a cell. In the first like this is showing 100%. It means this is fully charged. All these green bars showing, like these are 4 bars, this showing this is fully charged. If consider this is a whole, it's 100%. If one is consumed, remaining 3 parts, 1 part is equal to 25, so 3 parts equal to 75. If 1 is consumed, remaining 3 parts, that will be 75%. So out of total is 100, the remaining is 3 parts, that is 75%. It means 75% is left. If 2 bars are consumed, means half of the charging is consumed, then this is 50%. If total is consumed, there is nothing charging inside, so this will be the 0%. Hopefully percentage composition is now percentage is clear. So come to our topic, that is percentage composition. Composition means like a compound that is formed of different elements, different atoms. For example, water, that is H2O. This is formed by element hydrogen and oxygen. So what will be the percentage of hydrogen as a mass in this water, and what will be the percentage of oxygen as a mass in this compound? So that will be called a percentage composition. So this is the relative amount of each element in a compound are expressed as the percentage composition. So when we express the mass of element in a compound, then this is called percentage composition. And how can we find? This is very simple formula. Percentage of that particular element equals to mass of that element divided by total mass of the compound multiplied by 100. This is the equation to calculate the percentage composition. So this equation will be more clear with this example. For example, we have a compound magnesium oxide, MgO. It means magnesium oxide compound is formed with the help of magnesium and oxygen. One magnesium and one oxygen. This showing like this is 50-50, one magnesium, one oxygen. But we are bothering its percentage composition by mass. So let's see what is the mass percentage of magnesium, what is mass percentage of oxygen in this compound. So equation is like mass of that particular element divided by total mass of compound multiplied by 100. Mass of magnesium is 24 gram per mole and the mass of oxygen is 16. So mass of total compound will be 24 plus 16, that is 40. So percentage of magnesium will be 24 divided by 40 multiplied by 100. The answer is 60%. It means magnesium in magnesium oxide is 60% by mass. And what will be the percentage composition of oxygen? You can give the idea of out of 100, 60 is magnesium, how much will be oxygen? Yes, of course, 40, but we have to calculate it. Mass of oxygen 16 divided by total mass 40 multiplied by 100, that is 40. 60 plus 40 means 100%. If magnesium oxide total, this is 100. So out of this, magnesium by mass is 60% and oxygen by mass is 40%. Similarly, sometimes questions ask like, what do you know about percentage composition? How will you determine the percentage composition of each element in the substance? These two things we have already discussed. So the basic question here is how to attempt this question. So I'm repeating, you have to answer what is asked. You don't need to write more or like 3, 4 or 5 pages. Just exactly write the answer what is asked. In this question you have to ask what do you know about percentage composition. So you have to first define the percentage composition. Then if there is some formula, some equations or examples, then you have to write that equation or formula. In this case you have to write the first definition, then formula or equation to calculate the percentage composition. Then you have to give some examples. One example I have already discussed, and in the upcoming slide I will discuss some other examples. So add just 2 or 3 examples how to calculate the percentage composition, then this question answer will be complete. Now question is, glucose, that is a compound C6H12O6 is the most important nutrient in cell for generating chemical potential energy. You know this is a quick source of energy. So you should know what is the function of the glucose in our body. Calculate the mass percentage of each element in the compound, that is a glucose. So first of all, look, glucose is a compound. It is made of 3 elements. It's carbon, it's hydrogen and it's oxygen. In this compound there are 6 carbon, 12 hydrogen and 6 oxygen. So you have to find out the mass of each element as a percentage composition in this compound. So first of all, you have to write the data. For example, in this there is a 6 carbon, mass of 1 carbon is 12, so mass of 6 carbon will be 12 multiplied by 6, that is 72 gram per mole. Now the mass of hydrogen, total hydrogen in this compound, mass of 1 hydrogen is 1 and there are 12 hydrogen, so mass of 12 hydrogen will be 12 gram per mole. And then come to the oxygen, mass of 1 oxygen is 16 and there are 6 oxygen, so total mass will be 12 multiplied by 6, that is 96 gram per mole. And now you have to calculate the total mass of the glucose. We have already calculated in our previous lectures, that comes 180, but now here we will calculate it again. So mass of all carbons 72 plus mass of all hydrogen 12, mass of all oxygen 96. Add these 3 mass, their answer will be 180 gram per mole. So now apply the simple equation for each element. Percentage composition of carbon will be equal to mass of carbon in compound divided by total mass of the compound. So mass of carbon here is 72. This 72 is the mass of 12 carbons. 6 carbons divided by 180 multiplied by 100. So answer is 40%. It means carbon in this glucose by mass is 40%. Similarly, calculate the mass of hydrogen. Total mass of 12 hydrogen is 12 divided by total mass of compound 180 multiplied by 100. Answer is 6.66%. So hydrogen by mass in this compound is only 6.66%. Otherwise you can see there are 12 hydrogen and 6 carbon and 6 oxygen. Oxygen and carbon are half of the hydrogen, but actually we have to calculate the percentage composition. So as a percentage composition, hydrogen is 6.66%. Then come to the oxygen. So mass of 6 oxygen is 96 divided by total mass of compound is 180 multiplied by 100 and answer is 53.33%. So by percentage composition, oxygen is maximum in this, that is 53.3, and hydrogen is least, that is 6.66, and carbon is 40%. So if you add all these percentage like 40, 6.66, 53.33, the total will be 100. So as a whole glucose 100, out of this carbon is 40%, hydrogen is 6.66%, and oxygen is 53.33%. Students, hopefully percentage composition is clear, and now you will be able to calculate the percentage of any element in any compound. So I have given you some questions for your practice. Calculate the mass percentage composition of nitrogen in all of, like in ammonia, in N2O, in urea. So just apply the equation. First calculate the mass of nitrogen, total, if there is one nitrogen or two or three. So total mass of the nitrogen divided by total mass of the compound, multiply by 100. So you will find out the percentage composition of nitrogen. Question even can be asked, calculate the mass of carbon in this, like in the 3 NH2CO NH2. So calculate the mass of carbon. So it is not like always you will be asked about the percentage of nitrogen. You can be asked about the percentage of oxygen, you can be asked about the percentage of carbon, you can be asked about the percentage of hydrogen. So basically you know the how to calculate the percentage composition of element, and I'm sure this is now clear. Students, this was all about the percentage composition and how to calculate, and we have calculated the percentage composition of elements, solving some different examples. And our next topic, students, will be about limiting reactant and non-limiting reactant.